In this video, we'll talk about our fourth rule for solving equations, which is never divide both sides of an equation by a variable. Because if we do that, it turns out we can lose solutions. Okay, and then we'll see what do we end up doing when we're tempted to do that. Okay, so let's look at an example. So in example part A here, example 4, I got x squared equals x. Okay, so first I want to show you an incorrect way of doing this. I'm going to divide both sides. I'm going to divide both sides by a variable because I see there's an x on both sides. Maybe I'll try to divide both sides by x. And if I do that, on the left-hand side, well, x squared divided by x, that'll cancel an x and just leave me with x. And then on the right, x divided by x is just 1. But looking at this, if I look at the original equation, can you see another answer that works in this equation besides x equals 1? Pause it real quick for like 20 seconds and see if you can find another really small, simple answer that works if I just plug it into both sides. Okay, so hopefully paused it for about 20 seconds to think about what that might be. But notice that x equals 0 also works. Like if I just were to plug it in, x equals 0 also works as an answer. So, well, what happened? Because when I solved for it this way, I didn't get that as an answer. So something must have gone wrong this way. X equals 0 should have been an answer, but we didn't get it. So what's the problem with what we just did? Well, the issue is that this step where we divided both sides by x. When I divide both sides by something, what if I was dividing by 0? What if this denominator was 0? So this step over here, this is only true. I'm only allowed to do this as long as that denominator, which is x, is not equal to 0. But that happens to be the answer that we lost. X equals 0 is the answer that we lost. Okay. All right, so the moral there is, if you divide both sides of an equation by a variable, we can lose solutions as we just did. Instead, what we want to do is move everything over to one side and then try to factor. So let's do that. This is going to be the correct solution. Okay, so let's move all the terms to one side. Maybe I'll subtract the x over to the left. That'll give me x squared minus x equals 0. All right, and now let's factor, because there's the x in common. I can factor that out, and that'll leave me with x minus 1 equals 0. So now that it's factored and it equals 0, I can write down what my answers are. So from this first factor, well, I'll get x equals 0. And from the second factor, well, what would make that be 0? It's x equals 1. X equals 0 and x equals 1. Now we got both of those answers. All right. So let's look at another example. Let's up the difficulty. So part B. All right. So I got this kind of long product on the left, and I got a similarly long product over here on the right, and I want to solve this equation. So it's super tempting when I look at this to be like, wait, I have a bunch of the same factors. Like I have some 7 minus x's on the right, some 7 minus x's on the left. Could I, divide by some 7 minus x's to like some power? Well, if I do that, if I divide both sides by something with a variable, I can lose answers. So I don't want to do that. I don't want to divide both sides by stuff with variables. All right. So instead, move everything over to one side and then try to factor. So I'll keep the left-hand side as it is. And then I'll move the whole right-hand side over to the left. So all of this over here, I'm going to move it over to the left by subtracting. So minus 6 times 3 plus 2x to the 8 power times 7 minus x to the 5. And if I wanted to, I could have taken this whole thing and moved it to the right. It doesn't really matter as long as everything is on one side. Okay. And now I'm going to try to factor the common terms. All right, so first, let's focus on the coefficients, the 16 and the 6. So 2 is common to both of those. 2 is common. What else is common? Well, both of these have a 7 minus x, and I factor out the smaller power. I see a 6 here and a 5 there, but I'm going to factor out the smaller power. which is the 5. All right, all right. And then I also see both terms have this 3 plus 2x, so I can take out 3 plus 2x to the 7, because that's the smaller power. So that's everything that's common. Now I start a big old parentheses, and I write all the leftovers. So from this first term here, what's left over? From the 16, when I take out a 2, I'll have an 8 left over. And then I'll also have 7 minus x to the 1. So I don't need to write the 1 as an exponent, because I used to have 6 of those 7 minus x's, and I took out 5 of them. I won't have any 3 plus 2x's left over here because I took out all 7. All right, so now let's go to the second term. What are all the leftovers from the second term when I pulled out this common factor? All right, so when I pull out that common factor, I have that negative 6 in front. If I factor out a 2, I'll be left with minus 3. All right, and then I'll also have a 3 plus 2x left over, because I used to have 8 of them, but I took out 7. And then that's it, because we took out all the 7 minus x's from that second term. So those are all the leftovers. Close the parentheses. This equals 0. All right. So everything out in front, those are the common factors. I've taken them out already. Those are already fully factored. Let's just leave them out there. The stuff that we could simplify further is maybe the stuff inside here, all these leftovers. So let's distribute the 8. That's going to give us a 56 minus 8x. I'll distribute the minus 3. So minus 9 minus 6x. Let's combine some like terms. So that'll give us negative 14x. And then 56 minus 9. That's plus, 47? Plus 47. Okay, so we end up with 2 times 7 minus x to the 5 times 3 plus 2x to the 7. And then in parentheses, the leftovers become negative 14x plus 47. This equals 0. All right. So I got a big old product. It equals 0. So this means, either this factor equals 0, and you might just see right away, like what makes that be 0, but I'm really going to show it in steps. So I could take that whole thing, 7 minus x to the 5, set it equal to 0. And now to get rid of that fifth power, I could fifth root both sides. And when I fifth root the left-hand side, it'll cancel that fifth power, and I'll end up with 7 minus x. And the fifth root of 0 is 0. And if I move the x over, we get 7 equals x. Of course, we could have just seen that a little more simply by thinking about this and asking ourselves, well, what would I plug in for x? What would I plug in for x to make that be 0? And clearly it's 7. So if we saw that, we could have skipped all this algebra and jumped straight from here, straight to that step. Okay. All right, now let's go to the next factor. Let's go to that 3 plus 2x factor. So again, this time I am going to sort of jump the algebra a little bit. I'm going to go straight to the inside of that 7th power, which is that 3 plus 2x. And I'm going to set that equal to 0. And if I subtract the 3 over, and I divide the 2, we'll get x equals negative 3 halves. So x equals a negative 3 halves. All right, so one of our answers is x equals 7. We're getting that, or x could be equal to negative 3 halves. Or I got one final factor here, this thing. I can set that equal to 0. So, or that negative 14x plus 47 could be equal to 0. And if I rearrange this, we'll end up getting x equals 47 over 14. It's just 2 quick steps. Move one term over to the other side and then divide the coefficient, and we'll get this. So overall, we have 3 answers. X could be 7, could be negative 3 halves, or it could be 47 over 14.